Hi, and welcome to this video on graphing functions. Today, I'll be showing you how to graph a function. Specifically, we'll focus on the concept of slope, which determines how the function will take shape when we graph it. We will also discuss the relationships between the slopes of perpendicular and parallel lines. Let's get started. First, a quick reminder of linear functions. As you can probably guess by the name, a linear function graphs as a straight line on the Cartesian plane. The line represents every point on the plane that satisfies the linear equation. Each point can be expressed as an ordered pair, x, y, which represents the units on the x-axis and the units on the y-axis. The slope of the line is determined by measuring the vertical distance between the y values of 2 points on the line and dividing the horizontal distance, as determined by the x values of those points. Let's take a minute to apply this information with a few examples. Determine the slope of the line that passes through the points 3, 7, and 6, 3. The vertical distance, sometimes referred to as the change in y, or the rise, is calculated by subtracting the y values of these 2 points. 7 minus 3 equals 4. The horizontal distance, known as the change in x or the run, is calculated by subtracting the x values. 3 minus 6 equals negative 3. Note that the subtraction must be consistent. We subtracted both of the coordinates of the point G from the coordinates of point F. The slope of this line is therefore change in y over change in x, or negative 4 over 3. It is important to note that a negative slope indicates that the line slopes downward from left to right. Let's look at another example. Calculate the slope of the line that passes through the points 1, 1, and 4, 3. Step 1. Calculate the change in y. 3 minus 1 equals 2. Step 2. Calculate the change in x. 4 minus 1 equals 3. Step 3. Calculate the slope by dividing the change in y by the change in x. This gives us our final answer of 2/3. The slope equals 2/3 for this line. This means that the line will slant upward from left to right because the slope is positive. The ability to analyze a graph and knowing the attributes of slope are important skills. There are 2 special types of lines that do not follow the rules we just mentioned with regard to slanting up or down according to the sign of their slope. Here's an example. Calculate the slope of the line that travels through the points 5, 3, and negative 2, 3. This time, when we determine the vertical change, or the change in y, we get an answer of 3 minus 3 equals 0. Intuitively, this makes sense because there is no change in the y-coordinates from one point to the other. There is a change in x. However, dividing 0 by any value results in 0. The slope of this line is therefore 0 over negative 2 minus 5, which equals negative 7. But this still equals 0. This is true for any horizontal line that exists on the coordinate plane. These equations are written in the form y equals c, where c is any value on the y-axis. Accordingly, this line is the line y equals 3. Some people find it helpful to visualize a horizontal line with a slope that does not rise but runs forever. With similar reasoning, let's explore the nature of a slope for points that lie on a vertical line. Determine the slope for the line that passes through the points 2, 5, and 2, negative 1. Just by looking at these points, we can see that there is no change in the x values, so the denominator of the slope calculation will be 0. The slope for this line will be calculated as follows. Negative 1 minus 5 over 2 minus 2, which equals negative 6 over 0. You may remember that dividing by 0 is undefined. Vertical lines are written in the form of x equals c, where c is any value on the x-axis. This line is written as x equals 2. Note that there is no slope for vertical lines as they do not slant in either direction. These lines rise forever, but do not run. For the following graphs, indicate whether the slope of the line is positive, negative, 0, or undefined. Example 1. Positive slope. The line slopes upward from left to right. Example 2. Slope is undefined. All vertical lines have undefined slope. Example 3. Slope is equal to 0. All horizontal lines have a slope equal to 0. Example 4. Slope is negative. The line slopes downward from left to right. When graphing a linear function, the slope is extremely important. If we have one point in our slope, we can find every other point on the line and see what the line looks like. We just learned that in our slope-intercept form of our linear equation, y equals mx plus b, the letter m represents our slope. Remember, the letters x and y represent the x-coordinate and the y-coordinate of any point that satisfies our equation. Now, the only thing left we have to talk about in our equation is the letter b. B in our slope-intercept form represents the y-intercept of the equation. The y-intercept is the point where the graph hits the y-axis or where x equals 0. So the y-intercept gives us the point that we need to figure out our graph. The point will be 0, b for whatever number is in the b position. Let's try an example. What is the slope and y-intercept of the equation y equals 1/2 x plus 7? Our slope is our m value, so for this equation, slope is equal to 1/2. We determine our y-intercept by looking at our b value, which in this case is 7. Remember, this number gives us our y-coordinate for our point where x equals 0. So the y-intercept of this equation is 0, 7. Now that we know how to identify our slope and y-intercept, let's look at how we can use these two things to graph our equation. Our first step is to identify the y-intercept. For our equation above, we already did this. Our y-intercept is 0, 7. The second step is to plot that point on our graph. So we are going to place a point at 0, 7. Next, we want to look at our slope, which we found earlier to be 1/2. Remember, the slope is the ratio of our change in y over our change in x, or our rise over run. Fourth, we're going to use our slope to find another point on the line. Start at the y-intercept and move up, or rise, 1, and move right, or run, 2, and then place another point there. Since we have 2 points, we can make a straight line. So our final step is to draw a straight line between the 2 points, making sure to put arrowheads on either end of the line to indicate that it continues forever in either direction. And it's as simple as that. Let's try another example following the steps we saw above. Graph the equation y equals 2x minus 4. Step 1. Identify the y-intercept. Our b value in this equation is negative, so our y-intercept is also going to be negative. 0, negative 4. Step 2. Plot the y-intercept on the graph. Step 3. Identify the slope. Remember, the slope is our m value, so in this case it is 2. Step 4. Use the slope to plot a second point. When we are given a whole number, we can turn it into a fraction by placing it over 1. This doesn't change the value of the number because any number divided by 1 is itself. So our new slope looks like 2 over 1. This means that from our y-intercept, we are going to rise 2 values and run 1. Step 5. Draw a line between the 2 points. I want you to try one more. This time, try to do it without my help. Graph the line y equals negative 2/3 x plus 1. Think you've got it? Let's walk through it together. Our y-intercept is at the point 0, 1, so we're going to plot that first. Now we look at our slope, negative 2/3. This tells us that we are going over 3 places and down 2. We go down instead of up because our slope is negative. Now that we have our 2 points, we draw our line through them and add our arrowheads. Before we go, I want to look at a few more things about slope that are helpful to know. There are 2 more very important types of lines that have special slope relationships. Consider these graphs. These lines have the special relationship of being equidistant or parallel. That means that they are the same distance apart for each value on both the positive and negative sides of the x-axis. As we have discussed, the slope determines the slant of the line, and clearly, equidistant lines have the same slant. In other words, parallel lines have the same slope. The equations in slope-intercept form for these lines are y equals 2/3 x minus 1, and y equals 2/3 x plus 2. The slope of 2/3 is clearly identifiable in both equations. If given two equations, the lines are parallel if the slopes are the same. This graph shows two lines that have the special feature of intersecting at a right angle. As a result, these lines are considered perpendicular. The equations for these lines are y equals 3x minus 1 and y equals negative 1/3 x minus 2. Again, there seems to be a relationship between the slopes m equals 3 and m equals negative 1/3. Any guesses? Well, there are actually two distinct differences between these slopes. The signs are opposite, and the slope of one line is positive and the slope of the other is negative. The slope values are reciprocals, meaning that the numerator and denominator are flipped. If these two changes are recognized in the slopes of two linear equations, then the lines that they represent are perpendicular. Let's apply this information with some practice. See if you can answer these on your own. Example 1. What is the slope of a line that is parallel to y equals 5/7 x minus 2? Example 2. What is the slope of a line that is perpendicular to y equals 2/5 x plus 1? Example 3. State whether the lines are parallel, perpendicular, or neither. Y equals 3x plus 4, and y equals negative 1/3 x minus 8. Example 4. Try the same for these lines. Y equals negative x plus 5, and y equals 1/2 x plus 2. And one more, number 5. Y equals x plus 2, and y equals x minus 5. The answer to example 1 is the slope of this parallel line is equal to 5/7. Remember, parallel lines have equal slope. The answer for example 2 is the slope of this perpendicular line is equal to negative 5/2. Remember, perpendicular lines have slopes that are opposite reciprocals. The answer to example 3 is perpendicular. The slopes are opposite reciprocals. The answer to example 4 is neither. Slopes are not the same and slopes are not opposite reciprocals. These lines intersect but not at a right angle. And the answer to example 5 is parallel. Slopes are both equal to 1. I hope I've cleared up any confusion that you may have had with regard to slope and graphing linear equations. As you can see, slope is the driving force in graphing and holds the key to identifying special relationships between lines. That's all for this review. Thanks for watching and happy studying.